Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see what is Raman effect and why Sir C V Raman was awarded with Nobel Prize in 1930. Sir C V Raman discovered this effect in 1928 when he was in University of Calcutta, and he was the first Indian and first Asian who won Nobel Prize in Physics at that time. And this Nobel Prize was awarded to him for his work on scattering of light and for the discovery of the effect named after him. So as I told, Nobel Prize in Physics 1930 was awarded to him for his work on the scattering of light and for the discovery of the effect named after him, that is Raman effect. Let us see what is Raman effect and how Raman observed this phenomena. While studying scattering of light, Sir C V Raman found when a beam of monochromatic light was passed through organic liquids like benzene, toluene, etc., scattered light contains other frequencies, shorter as well as longer frequency than incident light. And such kind of observation was known as Raman effect. Let us see its experimental setup. In this experimental setup, intense mercury discharge lamp LLR displaced parallel and close to Raman tube, which is surrounded by annular check and J, through which is circulated through filtered solution to isolate mercury lines that I have shown in these images. Light reflectors capital RR are placed to increase intensity of illumination. Here we are observing scattered light passing through plane window of Raman tube, and spectrograph will take spectrum under long exposure. Here in first two images I have shown actual setup in schematic diagram, and in the third image I have shown actual experimental setup. In these two images we can see that there are three kind of wavelength in this spectrum. First one is the incident wavelength, second one is band of stock lines, and third one is band of anti-stock lines. Let us see what these are. The lines having wavelengths greater than that of incident wavelength are called stock lines, and those having shorter wavelength are called anti-stock lines. Stock lines are found to be more intense than the anti-stock lines, and most of the Raman lines are strongly polarized. This is the basic characteristic of Raman spectrum. Here, displacement of the modified spectral lines from the exciting line when measured in wave number, that is k, will depend only on scattering substance that I mentioned, like benzene, toluene, etc., and is independent of wave number k of exciting radiation. And Raman spectrum is thus characteristic of scattering substance, and that is why Raman effect is widely used to identify various molecules in condensed matter physics, in chemistry, etc. Another thing is Raman effect is quite different from Rayleigh scattering. In Rayleigh or coherent scattering, there is no change in wavelength, but in Raman scattering, scattered light exhibits modified wavelengths as well as original wavelengths. And for this reason, Raman effect is called incoherent scattering and considered as the optical analogy of the Compton effect, which is used to study particle nature of reality. There are several applications of Raman effect. First and foremost application is to identify molecular structure of substance. A qualitative identification of Raman spectrum consists in the evaluation of wavelength of the lines, their intensity and state of polarization. By investigating, we can find bond angles, bond stiffness, other structural conformation from Raman data regarding any substance. Raman effect or Raman spectroscopy is also widely used in biotechnology field, analytical studies, photosynthesis research, in biomedical research, in medical field, etc. So these are the application of Raman effect, and that is why Sir C V Raman was awarded with Nobel Prize in 1930. Thanks for listening. If you like my video, please share and subscribe my YouTube channel.